Hi, so in this presentation, we're going to start the very beginning of this book, The Power of Logic. And so it is covering a variety of topics in critical thinking and specifically focusing a lot on deductive logic. And specifically here, deductive validity and deductive soundness of arguments. And so we're going to be presenting kind of the basics here that we'll use for the other presentations. And we're going to start really simple, just to make sure that we've got the terminology in place very precisely. We're all sort of starting from the same starting point. So at the beginning here, it's going to be sort of like basic grammar, if nothing else. So just to start off some of the definitions, we'll be dealing a whole lot with statements. This kind of forms the basis for a lot of what gets talked about in the class. So a statement is just simply some declarative sentence, and it's a sentence that can be assessed for being either true or false. We compare the statement to reality and decide if the statement is an accurate description of the way reality really is. And then an argument in this context is just simply what it says here, right? A set of statements, which we call premises, that support another statement, which we call a conclusion. And so this, of course, is a little different than in regular language. An argument might be two or more people sort of yelling at each other or some kind of like heated debate or something. But that's not really necessarily what's going on here at all. An argument is just sort of a standalone set of statements that are intended to support another statement, to support a conclusion. And then when we want to look at how well those premises are supporting the conclusion, that's what logic is all about. So logic is just simply the variety of ways that we assess how well premises are supporting a conclusion. And so in logic actually is sort of its own field of research, we might call it. It's a little bit like theoretical mathematics, where in theoretical mathematics, the mathematicians are finding ways of establishing proofs, proving their theorems in mathematics, and a variety of techniques for establishing those proofs. And it's all a bit abstract, but once they've established these preferred and reliable techniques for establishing proofs, proving that their theorems are correct, then they can apply those theorems and those proofs to something real. And so that's very much what's going on here, that we are looking at a variety of techniques and strategies and so on for determining how reliably supported conclusions are in various arguments. And then we can take those techniques and methods and so on and apply them to real life situations or to actual real arguments that are talking about real things. But we'll get there, and we'll be having a wide variety of examples as we go along that will do this, that will apply these things to sort of real arguments. Okay, so just a little bit more. Some of this is repetition, but a statement, as I said, is a declarative sentence that can be assessed as being either true or false. So it's asserting a fact of some kind, or it's applying a predicate. And maybe you already know what that term predicate means, but a predicate is really just a characteristic or an attribute or an action or a state of being or something like that that we're applying to a subject. So we could say that Mike is talking, right? So Mike is the subject and is talking is the predicate that's being applied to me, not Mike. Then we can compare that statement to reality to determine whether it's true or false. That is, to determine its truth value. And in this case, the truth value is true because Mike is in fact talking right now. Okay. And this is perhaps fairly obvious, but nevertheless, a statement is different than other sorts of sentences like questions or exclamations or just a proposal about what we should do or shouldn't do, or a command telling somebody to do something. These are all obviously like very common sentences, but none of them are statements. None of these can actually be assessed as being true or false. So if I just ask a question itself isn't true or false. It's the statement that's an answer to the question that could be true or false, or just a command, close the door. Like, that's just telling you what to do. That's not a statement that can be assessed as being true or false. Okay, So here's just a couple of really quick, simple arguments. These are examples that we'll use later on, but just so that you can see what's coming up here, it's just 3 simple examples of arguments. And so these are obviously statements that are used to support a conclusion. And in each case, the conclusion itself is also a statement. And notice here that, and this is something that's going to be going on over and over and over again throughout the whole class, that we frequently number the premises. So premise 1, premise 2, just so that we can refer to them more easily as just premise 1 or premise 2, rather than having to read out the premise every time. And very often, although I don't have it here, but very often the conclusion itself will also be given a number so that we can just refer to the number again rather than having to say the conclusion or read out the conclusion every time. And it just so happens that each of these example arguments that I have consists of 2 premises and a conclusion. But of course, arguments can come in a wide variety of sizes. And so there could be just 1 premise for a very, very simple argument, or there could be a lot of premises. So here's one where we've got 5 premises and a conclusion. This is coming from René Descartes, who's very famous. He's sort of the founder of modern philosophy, usually he's considered that. And so you might recognize him as the person who said, I think, therefore I am. So the idea was that he's a thinking person. He knows that he exists because he's thinking, but then he's worried about whether his sensory systems are giving him accurate knowledge about the way the world really is. And so here's his famous argument for why our sensory systems are reliable. Feel free to read that over, pause this and read that over if you want. That's not the focus of this class. Other classes will have more of a focus on these actual arguments. This is just a class focusing on sort of arguments in the abstract. What are arguments like? How do we assess them? Rather than trying to think about these specific arguments and whether we agree with them or not. But here's another one, just to give you a little flavor of the kinds of arguments that you might see in another philosophy class, of like an ethics class or a metaphysics class. And so, these premises are fairly complex, and they do a lot of work to try to justify those premises. But nevertheless, this is, standard format, number the premises, and they're intended to support a conclusion. Okay, so again, logic, just in general, is the assessment of how well the premises are actually supporting a conclusion. And here's another technical term that we need to make very clear here. When we say proof, that an argument is proving the conclusion, this means that the conclusion is 100% guaranteed to be true, absolutely impossible for the conclusion to be false. And this is perhaps a little bit different than the way we often use this term proof in regular language. Usually, or at least sometimes, this term proof is used in a somewhat softer way. That is, if we say that something is scientifically proven, we usually mean that the scientists have given us lots and lots of good evidence in support of that conclusion. But as we'll see in a later class, this is always going to be, almost always going to be, somewhat short of 100% guarantee that the conclusion is true. So think of something big, like the Big Bang. Has science proven that the Big Bang happened? Well, we've got lots of good scientific evidence in favor of the Big Bang theory. But even if we want to say that that's 99% likely to be true, it's still not proof in this strong sense of the term that we're going to be using over and over. And here I'm going to sort of enforce this use of the term proof to mean 100% guaranteed that it's true, rather than merely just supporting. Okay, so if we're talking about arguments that do establish 100% proof of their conclusions, then we're talking about deductive logic. That's what deductive logic does, is when it's done properly, it's set up such that the conclusion is 100% guaranteed by the premises. However, if we're dealing with an argument that doesn't quite do that, that it maybe supports the premises, but not all the way to 100% guaranteeing that the premises are true, then that's inductive logic. That's where inductive logic plays a role. And inductive logic we'll talk about later. For much of this class, it focuses on deductive logic, but inductive logic will show up too. Okay, so this is, of course, if we're talking 100% guarantee of the truth of the conclusion, well, that's the highest possible standard that you can have. And that's the sort of thing that you see very often in math and geometry. It's a little harder to get 100% proof on sort of everyday things or sort of real life things that science might be studying. But nevertheless, this is sort of what deductive logic is intended to do. Okay, so what we're going to then focus on for the rest of this session is deductive validity, how an argument can be deductively valid, what that means, and a few examples of deductively valid arguments. Okay, so here's a couple of different ways, in fact, 3 different ways of describing what it means for an argument to be deductively valid. And in fact, I should maybe say a little bit more about just the terminology here. The term valid, the way that's often used in regular language, could mean just true or useful or good somehow. Here it's used in a very specific technical way. And here's sort of the 3 different ways of describing this technical sense of being deductively valid. So if we've got an argument that's set up such that if the premises are true, they guarantee that the conclusion must be true, 100% guarantee that the conclusion must be true, then that's a deductively valid argument. So if the premises are true, then its conclusion, the conclusion of the argument is 100% guaranteed. Another way of saying that is that it's impossible for the premises to be true if the conclusion to still be false at the same time. Those are all just different ways of describing the same concept of deductive validity, a deductively valid argument. So here's a really common sort of introductory, simple example of a deductively valid argument. So it's deductively valid because if these premises are true, then the conclusion is guaranteed to be true. If it's really true that all humans are mortal, and it's really true that Socrates is a human, then it's just absolutely inescapable. It's got to be the case that Socrates is mortal. Since he's a human and all humans are mortal, then he's got to have that attribute too of mortality. And notice that this argument has a specific form. This idea of forms of arguments is going to come up over and over again throughout the class. And the form of an argument is just sort of the pattern or the structure of the argument. So this is a really common, simple, straightforward argument form. So it's just saying, if we abstract the form and separate out any specific content, like being Socrates or being mortal or anything, then we see that the form of this argument is just this. All A's are B, something X is an A, so therefore that thing X must also be B. And A and B here are standing in for terms, right? In the original argument, A was Socrates and B was mortal. Or I'm sorry, A was humans and B is mortal, and then X was Socrates. And so anytime that we see this argument form, it doesn't matter, what might get substituted in for A and B, as long as it's done consistently, then the result is going to be a deductively valid argument. So in our original version, we had A, substituted humans in for A, mortal was substituted in for B, and Socrates was substituted in for X. But that doesn't, we could substitute anything in for A, B, and X. And as long as we do it consistently, whatever we put in for A in premise 1, we have to put in for A in premise 2. Whatever we put in for B in premise 1, we have to put in for B in the conclusion, and so on. As long as we're consistent in that way, then this is going to give us a deductively valid argument every time. It's just absolutely guaranteed. That's great, but it's not actually good enough to be a deductively valid argument. That's a good thing, right? We're sort of on the way to a good argument, but just simply being deductively valid in and of itself isn't good enough. We also want the premises of this argument to actually be true. And in order to assess that, we need to sort of see what's been substituted in for A, B, and X. And then we can decide whether that argument somehow matches the real world. The premises, the statements that make up the premises, are matching the real world in such a way that we would say that those premises actually are true. And so that might seem obvious, but look at this example. It has the exact same form as the arguments we were already looking at. It's just that instead of mortal, I substitute in green here for B. So all humans are green. Socrates is a human, so therefore Socrates is green. Well, technically this is a deductively valid argument. If it's really true that all humans are green, and if it's really true that Socrates is a human, then it's got to be the case that Socrates is green. There's just no getting out of it. Now, of course, we know if we start comparing these premises to the real world, we can see that that first premise turns out to actually be false. But if it were true that all humans are green and that Socrates is a human, then it would be guaranteed that Socrates is green. And so this is technically a deductively valid argument. But since the first premise is not true, the argument ultimately fails. And so it's not good enough to be a deductively valid argument. We also want the argument to be deductively sound. So a deductively sound argument is one that's first deductively valid. It's got to be that. But it's deductively valid and all the premises are actually true. So that first one about Socrates being mortal, that one's deductively sound. The premises, if the premises are true, they guarantee that the conclusion is true, and it turns out that the premises are really true. And so that first example was a deductively sound argument, as opposed to this one about Socrates being green, valid, but not sound. So as I mentioned before, these kinds of deductive arguments, especially when we're talking about deductively sound arguments, they're sort of airtight, just absolutely guaranteed perfect arguments. Those are pretty common in mathematics and geometry, but a little harder to establish in sort of real life situations. Even that one about Socrates being mortal, that first premise, Socrates is mortal, we accept that premise as being true. I think it is true, but we would need to have some evidence. We would need to have sort of another set of arguments to convince us that that first premise is true. And that's for an even very simple one, like Socrates is mortal. If we're talking about more complex arguments, then there might be a lot of debate as to whether the premises are really true or not. And some people might agree, some people might not. And so establishing that an argument is deductively valid, that's relatively straightforward, sort of a structural thing about the argument. But whether it's deductively sound, that can be a little bit trickier in real life examples. And we'll certainly see a bunch of examples of that. In fact, here's one right here. So all humans are selfish. Socrates is a human, therefore Socrates is selfish. Same form as we already had, so we know that this is a deductively valid argument. If those premises are true, then the conclusion's got to be true as well. But that first premise, is it true? Is this argument sound? Just take my word for it for the second premise that Socrates is human. Let's just sort of set that one aside and just assume that it's true for now. But that first premise, are all humans selfish? Like, well, humans do selfish things, but then at the same time, we can also recognize some examples where humans are not acting selfishly. Maybe they're helping other people somehow. Maybe they're even sacrificing their own self-interest under certain situations. So we would need to draw upon psychology and sociology and maybe a variety of other fields of research and common sense and all sorts of things in order to have a big debate about whether that first premise is actually true or not. In fact, we might even need to zero in on that term selfish. What exactly do we mean by selfish? We might need to establish that before we can determine whether that first premise is true or not. So in a regular philosophy class, most of the game, most of the work is about whether the premises are true or not. The debate is over whether the argument is deductively sound, by determining whether the premises are true. But whether it's deductively valid, that's a little easier. It's more, like I said, a sort of a structural component of the argument. And so that's sort of less interesting area of debate. Whereas debating over the truth of the premises, that's where the main game is at. Okay. So as it turns out, most arguments that you're likely to come across, especially sort of out in the real world, are deductively invalid. That is, they might provide some support for the conclusion, but it's not going to be 100% guarantee that the conclusion is true. Even if the premises are all true, they might still fall short of providing 100% guarantee that the conclusion is true. And if that's the case, then what you're dealing with is a deductively invalid argument. Now, it still might be a very useful argument or a very interesting argument, but we can't say under those circumstances that it's deductively valid. We have to admit that it's invalid. And if it is invalid, but still providing some support, then what we're dealing with is induction or inductive logic as opposed to deduction. And we see these kinds of arguments in science, in statistics. You know, they might provide a variety of really good reasons for believing the conclusion, but might not provide full 100% guarantee that the conclusion is true. So look at this one. It's maybe sort of obvious what's going on here, but it's got a similar form to what we've been dealing with so far, but not exactly the same. So the first premise says some humans are tall, then the second premise tells us that Socrates is a human, so therefore Socrates is tall. So clearly this is not deductively valid. This is deductively invalid. That even if the premises are true, it could still be the case that the conclusion is false. And so that sort of violates the definition of deductive validity. So this argument is deductively invalid. Now, it provides some support for the conclusion. If it's true that some humans are tall, which it is, right? If we assume tall means maybe 6 feet and above or something like that, then yeah, it's true that some humans are tall. And again, just sort of take my word for it that Socrates is a human. So even if those first premises, even when the premises are true, like they provide some support for the conclusion. It's certainly possible that Socrates was tall or is tall, but it's also possible that he's short. So it's deductively invalid, and it's sort of a weak argument still, but it is an inductive argument in favor of this conclusion. This one too, just to provide another example, even when we're inclined to think that the conclusion is in fact true, still this is a deductively invalid kind of argument. It could be that Socrates is female. This is maybe a somewhat unusual name for a female, but that doesn't matter. As long as it's an open possibility that Socrates is female, then it's possible that this conclusion is false, even when the premises are true. Some humans are male, yeah, that's true. Socrates is a human, again, take my word for it that that's true. So therefore Socrates is male? Maybe. So it's still, technically speaking, deductively invalid. All right. Here's another one. This is sort of a silly example, but nevertheless, it's worth presenting a few silly examples just to sort of get the terminology sort of straight in our head. This is a kind of an argument. Technically speaking, it is an argument. We've got two premises and a conclusion, two statements, and then a conclusion statement. This is clearly deductively invalid because the premises could be true and the conclusion still false at the same time. And it's doesn't even really count as an inductive argument either, because those premises seem to be completely unrelated to the conclusion. They don't even provide any kind of real support for the conclusion at all. But nevertheless, we've got some numbered premises here and a conclusion. So in a technical sense, this is still kind of an argument, but it's not the kind of argument anybody would actually be interested in. And certainly it's not deductively valid. Okay. So there are a few forms of arguments, like I mentioned an argument form before already. So an argument form is just sort of the structure, the pattern of the argument. There's a few that are really famous. We saw one already, about all humans are mortal, Socrates is a human, therefore Socrates is mortal. That's a really famous argument form, but it's not one of the kind of standard argument forms that people in logic like to really establish as a standard form. And so we'll look first here at a few argument forms that are always going to be deductively valid. So here's the first one. In fact, this one is so common that they gave it this sort of fancy Latin name, modus ponens. is how that's pronounced. And so here's the modus ponens argument form. And notice we don't have any specific content here. It's just all done in terms of A's and B's. And also notice here that A and B in these argument forms, they stand in for statements, as opposed to what we had before. A and B was standing in for terms. Remember, A could be humans, and B being mortal, and then X being Socrates. Here, A and B are whole statements, as we'll see. So, really famous argument form, kind of an if-then, proving that something is true. So if A is true, then B is true. And then the second premise tells us that A is true, so therefore we conclude that B is true. And this will be deductively valid for any consistent substitution of A and B that we come up with. Doesn't really matter what we put in for A and B, this argument will be deductively valid. Now, if it's deductively sound, well, once we substitute things in for A and B, we can compare those premises to the real world and decide whether those premises are actually true or not. But as it stands, these arguments will be deductively valid at least every time. So, well, here's just sort of a shortened version so that we don't have to write it all out every time. We could just say if A then B, and the second premise just says A, so like A is true, and then we conclude that B. And so now let's substitute in something that resembles what we had before. We can convert our Socrates' mortal argument into this modus ponens form, and it would look like this. If Socrates is human, then Socrates is mortal. That's kind of a way of saying all humans are mortal. You know, it says like if he's human, then Socrates is mortal, because we know that humans are mortal, so we can go ahead and say this. And then the second premise tells us Socrates is human, so we're forced to conclude that Socrates must be mortal. So if these premises are true, then that conclusion is guaranteed. So this is a deductively valid argument. And it looks like this is also a deductively sound argument. It seems like these premises are in all likelihood true. Like I keep saying, the second premise, you just have to kind of take my word for it for now, that Socrates is human. And it does seem true that if Socrates is human, then Socrates is mortal. So we're forced to conclude that Socrates is indeed mortal. Now we could do the same thing with Socrates being green. Right? I mean, it's the exact same format. It's the modus ponens form. I'm just substituting in mortal for green, or green for mortal. And so it's still deductively valid. Like there's no escaping that. It's the modus ponens argument form, so it's deductively valid. But now that first premise, if we compare it to reality, we can see that that first premise is actually false. So although it's deductively valid, it's not deductively sound. And that's what these famous forms are all about, is just determining whether something is deductively valid, whether this argument is deductively valid. It's another question whether these arguments are going to end up being deductively sound. So here's another example, same argument form as the modus ponens form. So if some object is red, then it's colored. Then this object, I'm calling it object X, is red, so therefore object X must be colored. If those premises are true, then the conclusion is guaranteed. So this is a deductively valid argument. So here's another argument form, a very famous one as well. It's similar to modus ponens, but this is modus tollens. And so this is sort of the negative version of modus ponens. Starts off the same. If A is true, then B is true. But the second premise is where sort of the negative stuff comes in. So now, in modus ponens, remember it said in the second premise, A is true. Well, here, the second premise tells us B is not true. And then we conclude that therefore A is not true. And just like with modus ponens, this argument will turn out to be deductively valid no matter what we substitute in for A and B, as long as we substitute them in a consistent way. You know, we don't switch what A is from premise one to the conclusion or something like that. So as long as it's a consistent substitution for A and B, then it doesn't matter what A and B actually are. This argument will be deductively valid. Again, it's another question whether it's deductively sound. Once we do a substitution, then we'd have to assess whether these premises are really true or not to determine whether it's deductively sound, but it will be deductively valid every time. Here's just the shorter version of modus tollens. So here's sort of our Socrates example again. If Socrates is human, then Socrates is mortal, okay? Premise 2 says Socrates is not mortal, because remember, it's got to match this modus tollens form now. So Socrates is not mortal, so therefore Socrates is not human. Well, this is deductively valid. If it's true that if Socrates is human, then Socrates is mortal, and it's true that Socrates is not mortal, then Socrates cannot be human. Because if he was human, he'd be mortal. So this is a deductively valid argument. If the premises are true, then the conclusion is guaranteed to be true as well. Here's the colored object example. So if an object is red, then it's colored, okay? Then premise 2, though, tells us that this object X, whatever it is not colored, doesn't have any color at all. So is it possible for the object to be red? No, it's impossible, right? And so if these premises are true, then the conclusion is guaranteed to be true. And so again, we see this is a deductively valid argument. I guess just if you want to think about applying this to a real world situation, you could think of object X as a big chunk of glass, like transparent glass, right? So there's no color there at all. But it would still be true that if that object is red, then it's colored. I mean, if it's red, then it's colored, yeah, sure. But it turns out that object X is not colored. It's a chunk of transparent glass. So therefore, object X is not red. Here's another argument form that's going to turn out to be deductively valid every time. It's got this somewhat fancy name, disjunctive syllogism. A syllogism is just sort of a pattern of reasoning, just sort of a conclusion that can be drawn from certain sorts of premises. A disjunction is an or. And so this is this or that. That's a disjunction, as they call it in logic. And so that's what the first premise gives us. Either A is true or B is true. A shorter version of that is just to say A or B. Then the second premise tells us that A is not true. That is, not A. So therefore, B must be true. And notice here that the disjunction, or, is, as we call it, the inclusive or. That's kind of the standard default in logic, is that anytime you see or, it's the inclusive or, which means either A or B or both. Just as a contrast, the exclusive kind of or would be A or B, but not both. It's got to be just one or the other. That would be the exclusive or. But again, just to make it clear, in logic, the default assumption, unless it's specifically stated otherwise, the default assumption is that the or is the inclusive or. So A or B or both. And so that's what's being used here. And of course, I just picked A for the second premise here, that A is not true. It would work just as well if the second premise said that B is not true, and then we would conclude that A must be true, because the first premise tells us that at least one of them has to be true. And so if one of them, it turns out, is false, then the other one has to be true. So here's an example, right? Sports examples work well here. Specifically sports in which ties are not allowed. They just keep playing until one team wins. So that's true in basketball. So either the Denver Nuggets or the Phoenix Suns won the game. The Suns did not win the game, so therefore the Nuggets won the game, right? So pretty straightforward kind of argument form. Here's another argument form that's always going to turn out to be deductively valid. This is perhaps a fairly familiar one. So if A, then B, whatever A and B are. And then the second premise tells us that if B is true, then C is true. So therefore, we can conclude that if A is true, then C is true. And by the way, notice these three sort of dots here and a little triangle. That's the shorthand for therefore. Just so that we don't have to write out the word therefore over and over again, I'll often use these three dots to represent therefore. So if A is true, then B is true. Second premise tells us if B is true, then C is true. So therefore, if A is true, then C is true. So here's an example of that hypothetical syllogism that's kind of familiar to us, but we have to pick a few different terms to get it to fit into this argument form. So if Socrates is human, then Socrates is a mammal. If Socrates is a mammal, then Socrates is warm-blooded. So we can conclude that if Socrates is human, then Socrates must be warm-blooded. Okay, so here's another one. This is the last one that I'll show you guys, last deductively valid argument form that I'll show you in this presentation anyway. So they call this one constructive dilemma. So it's a little more complicated, but as we look at an example, it turns out not to be that difficult to recognize. So the first premise is a disjunction, either A is true or B is true. And then the second premise tells us that if it turns out that A is true, then C is true. And the third premise tells us that if B is true, then D is true. And so we can conclude that either C or D is true, or both. So here's an example, again, from sports. So first premise is the disjunction, either the Yankees won or the Red Sox won. If the Yankees won, then New York is happy. If the Red Sox won, then Boston is happy. So therefore, either New York is happy or Boston is happy. Okay, so this reason for presenting these basic, very well-known forms of deductively valid arguments is so that we can use the famous forms method for determining whether an argument is deductively valid. And so, as it says here, all you got to do is determine the form of an argument. So suppose you're given a paragraph from some work of literature, or somebody's presenting their case, maybe it's a court case or something, they're trying to make this argument, and you want to find out if their argument is deductively valid. We're going to have a bunch of different ways of doing that coming up in the class, but here's a very straightforward way. So you just first figure out what the form of their argument is, and if their argument matches one of these famous deductively valid argument forms, then your work is done. You know automatically that their argument is deductively valid. Now you might also then have to go on to find out whether the premises really are true or not to see if you've got a deductively sound argument, but at least you know that the argument is deductively valid if it matches one of these famous deductively valid argument forms. Okay, so one of the things you need to watch out when doing this is you need to watch out for what are called formal fallacies. That is, argument forms that look kind of a lot like one of the famous deductively valid argument forms, but there's something a little bit wrong. There's something off about it. And so it turns out that the argument form is deductively invalid, but it can fool us because it looks so much like one of the deductively valid argument forms that we're fooled into thinking that it is deductively valid, but it turns out not to be. And so in the next presentation, that's what we'll look at is some formal fallacies. All right, so I'll stop there.